Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 2 variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, then also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 part A says compare scalar and vector quantities. Very common question. You need to understand what is difference between scalar and vector. Scalar quantities, they only have magnitude. So scalar quantities, they only have magnitude, but vector quantities, they have magnitude and direction. So this is the difference. This is how you need to compare. They have magnitude and also they have direction. So these 2 points you have to mention. You can say scalar and vector quantities, they have magnitudes, but scalar quantities, they do not have direction. So in our answer we have to write down 2 points. We can mention these 2 points in our answer. If you have mentioned, you will get 2 marks. Scalar and vector have magnitude, vector has direction, and scalar does not have direction, and this question has 2 marks. Part B says the radius of a small sphere is determined from a measurement of the volume of the sphere. The sphere is submerged in water, displacing some of the water into a measuring cylinder as shown in figure 1.1. The measured volume of displaced water is 28.0 plus minus 0.5 centimeters cube. Calculate the radius in centimeters of the sphere. So we have volume of sphere. So first of all, we can write down volume of sphere is equal to 4 by 3 pi r cube. We need to find out value of radius, so we can rearrange. So this is 3 times volume of sphere divided by 4 pi. Now we need value of r, so we have to take cube root on both sides divided by 4 pi cube root. So this is cube root. Now simply you need to plug in values. Volume of sphere is 28.0 centimeters cube. We no need to convert this unit because final answer has to be in centimeters. So this is divided by 4 pi and the power of this one is 1 by 3. So if we solve this one, we will get 1.9 centimeters. And this is radius up to 1 dp, because this is also precise up to 1 dp. So our final answer is 1.9 centimeters. Second part says calculate the percentage uncertainty in the radius of the sphere. And radius of sphere we have already discussed is equal to 3 times volume divided by 4 pi and cube root of this side, cube root. Now we need to calculate percentage uncertainty in R. Percentage uncertainty in R. If you look at these given quantities, you can see this is constant. So this one is constant. So it simply means that the percentage uncertainty in R is 1 over 3 of percentage uncertainty in volume. So this is the main thing you need to understand. Now simply we can write down here 1 by 3 how we can calculate percentage uncertainty in V. So we have absolute uncertainty, this is delta V, and this one is V. So this is simply equal to delta V by V multiply by 100. Now simply we need to plug in values. Delta V is 0.5 and V is 28.0 multiply by 100. So if we simplify, we will get 1 by 3 and here we will get 1.79%. Now if we solve, we will get 0.6% up to 1 SF. So this is our final answer, 0.6%. So this is how you can calculate. Question 2 says a hot air balloon floats just above the ground. The balloon is stationary and is held in place by a vertical rope as shown in figure 2.1. Balloon has a weight of 3.39 times 10 to 4 newtons. Tension in the rope is 4.00 times 10 to 2 newtons. Upthrust acts on the balloon. The density of the surrounding air is 1.23 kg per cubic meter. Far part A1 on figure 2.1, draw labeled arrows to show directions of 3 forces acting on the balloon. So first of all, we can simply draw one force, that is the weight of the balloon. We can simply say weight of the balloon is acting downwards. So we can say this is weight of the balloon, and upthrust will be acting vertically up. So we can say this is upthrust. thrust. The third force is the tension. Is the tension is up or is the tension is down? So you need to understand this balloon has tendency to go up. If no string, no rope, it will go up, but now string is pulling this balloon down, so the tension in the string is down. So we can say this is tension, so the tension is down. So this is how you need to draw these three forces. Tension is down, tension is not up, because the rope is pulling balloon downwards, so the tension is in downward direction. Now for the second part, we need to calculate the volume of the balloon to three significant figures of the balloon. Three significant figure, we need to calculate volume. So in this case, we can simply write down up thrust. This is equal to tension in the string plus weight of the balloon, because the mass of the string is negligible. From here we can write down up thrust, this will be equal to rho Vg time tension times weight of the balloon. We need to find out volume of the balloon, so simply we can say this is equal to tension plus weight divided by rho times g. Now simply we need to plug in values. Tension is 4.00 times 10 to 2 newtons, and weight of the balloon is 3.39 times 10 to 4 newtons. Density of surrounding air is given, that is 1.23 kgs per cubic meter, and we have value of g, that is 9.81. Now simply we need to calculate this one. If we calculate, our final answer will be 2.84 times 10 to 3 meter cube. So this is volume of the balloon, means 2.84 times 10 to 3 cubic meters. This is volume of the balloon. Question says the balloon is released from the rope. Calculate the initial acceleration of the balloon. Acceleration, simply we can calculate if we have value of the net force on the balloon and we divide by mass of the balloon, we can find acceleration of the balloon. We have discussed in the previous part, when this balloon was stationary, it's not moving, stationary. Forces on this balloon are balanced. We have discussed that up thrust is equal to T plus W. And now when we cut this rope, net force, we can say F net will be equal to U minus W. And from here we can see this is equal to T. So it means F net is equal to tension in the rope when balloon was stationary. So simply we need to plug in value of T here. That is F net, and value of T is given to us in the previous part, that is equal to 4.00 times 10 to 2, and we need to divide by mass of the balloon, but we have weight of the balloon, means W divided by G. So this is mass of the balloon. Now we can plug in values here, 4.00 times 10 to 2, and this is divided by weight of the balloon, that was 3.39 times 10 to 4, and we need to divide this by 9.81. So this is the mass. Now if we simplify this one, we will get 0.12 meters per second. So this is initial acceleration of the balloon. Part B says the balloon is stationary at a height of 500 meters above the ground. A tennis ball is released from rest and falls vertically from the balloon. A passenger in the balloon uses the equation v square is equal to u square plus 2as to calculate the ball will be traveling at a speed of approximately 100 meters per second when it hits the ground. Explain why the actual speed of the ball will be much lower than 100 meters per second when it hits the ground. So first of all, if you look at this equation, we need to understand when we can use this equation. V square is equal to u square plus 2as. It started from rest, so simply we can say v square is equal to 2as. In the calculation, passenger has used A is equal to G. A is equal to G, and this is equal to 9.81 meters per second. And passenger got answer, that is approximately 100 meters per second. But actually when the ball is falling, there is air resistance as well. So when the ball is falling, there are two forces acting on the ball. One is the weight. So this is assuming only force acting on the ball is the weight. So the net force in this case, net force will be equal to mg. But in this case, when there is air, so there is force by air. Upward mean air resistance is upwards. So the net force in this case, F net, this will be equal to W minus F air. So it means the net force in the second case will be lower, and A is equal to F net over M. So if F net is lower, it means value of A will be lower. If value of A is lower, it means that the final velocity that will be lower. So these are the points you need to understand to answer this question. I hope it makes sense to you. Let me show you the answer, how you can write down your answer. In your answer, you can talk about these points. You can simply say there is air resistance which increases with speed. So as this ball is falling down, ball is accelerating, speed of the ball is increasing, so air resistance is also increasing, because air resistance depends on speed. Means harder you hit the air particles, they will apply more force on the ball. Means as ball is moving faster, ball is hitting on air particles harder and harder. So air particles are hitting on the ball harder and harder. So that's the reason air resistance increases with speed. Average resultant force is less than weight, as we have discussed here. Means the average, this resultant force, this will be less than weight, because this is minus air resistance. Or we can say average acceleration is less than g, as we have discussed here. In this case, average acceleration, this will be less than g in presence of air. So final speed is less than 100 meters per second, because if A is lower, it means V will be lower. So this is how you need to answer. Just read question carefully and try to use your understanding of physics. So it's very important. If you start solving questions based on understanding, you will develop yourself very fast. But if every time you look at the question, you check the mark scheme and write down your answer, you will never develop your understanding. So when you see a new question, always do by yourself. Try to use your understanding of physics and answer the question, not just quickly look at the answer, because that will never develop. Your brain will not develop understanding of physics. To develop your understanding of physics, you have to first try by yourself, so your brain will start working in the same way. So it's very important, always do question first by yourself. Where you get stuck, then ask for help, but not you just look at the question, look at the mark scheme. That is not good. That is not physics. That is just a way to memorize. In physics, if you memorize, you will never develop yourself, and always you will be struggling with unseen questions. Part C says, before the balloon is released, the rope holding the balloon has a strain of 2.4 times 10 to minus 5. The rope has an unstretched length of 2.5 meters. The rope obeys Hooke's law. For part C1, show that the extension of the rope is equal to this. So first of all, we need to understand what is given to us. So we have value of L naught, then we have value of strain. So this is value of strain. So simply we need to understand strain. This is equal to delta L by L naught. For this question, we need to find out delta L. So delta L simply will be equal to epsilon times L naught. I mean, this is the strain. This is representing strain. And value of strain we have, that is equal to 2.4 times 10 to minus 5. Strain has no units, and L naught is 2.5. And if we solve this one, we will get 6.0 times 10 to minus 5 meters. So this is value of extension. Second part says calculate the elastic potential energy of the rope. So elastic potential energy, simply we can calculate, this will be equal to 1/2 F times delta X. Very straightforward one, if the concept is clear. But I'm quite sure most of you are not clear what this F is representing. F is actually the maximum force acting on the rope. So or simply we can say this is the force acting on the rope. Force acting on the rope. Very important one. In case of spring, when we apply force on the spring, so this will be the force, maximum force acting on the spring. So that is F. Now we need to understand what is delta X. Delta X is the extension. So this is extension. So you have to be very clear about this one. Actually, EP, this is equal to the work done on the rope. So this is equal to work done on the rope. Work done on rope. So this is equal to the average force time extension. So this is the distance, and average force is force started from 0. So means you have F plus 0 divided by 2 times delta X. So this is the maximum value of force acting on the rope. Means in this case it is tension in the rope. Now simply we need to plug in values. So we have 1/2, and value of tension we have that was given to us in the last part, and that is equal to 4.0. 0 times 10 to 2, and extension we have just calculated here, that is equal to 6.0 times 10 to minus 5. Now if we solve this one, we will get EP is equal to 0.012 joules. So this is the elastic potential energy of the rope, and this is how you need to calculate. So you need to understand what this F is representing, what this delta X is representing. So this is our answer. Question says the rope holding the balloon is replaced with a new one of the same original length and cross-sectional area. The tension is unchanged and the new rope also obeys Hooke's law. The new rope is made from a material of a lower Young modulus. State and explain the effect of the lower Young modulus on the elastic tension energy of the rope. We have already discussed that elastic tension energy, this is equal to 1/2 F times delta X, and F is the tension in the rope, and in the question it is given to us tension is unchanged. It means this F is unchanged. Now simply we need to look at delta X, how delta X is changing. If delta X increase, EP will increase, and if delta X decrease, EP will decrease, and if delta X stays same, it means EP will also stay same. So we need to look at Young modulus. It is given to us lower Young modulus. So simply we can say E, this is equal to F divided by A, means stress divided by strain. So we can say this is delta X divided by X. Now if we rearrange, we can write down this is F times X divided by A times delta X. So we can make delta X the subject. So we can say this is equal to Fx divided by A times Young modulus. For this question it is given to us F is the same. So this is same as before. X is the same, and cross-sectional area of the rope is also the same. But now the new rope, it has lower Young modulus. It means delta X will be greater. So if delta X is greater, it means EP will be greater. So it means more extension. So EP is greater than before. So let's try to understand this one in the different way. It means that same force has been applied for longer extension. Means the work done by the same force in this case is greater. We apply same force but for greater displacement. So the work done is greater. So it means more work is done. So more elastic potential energy is stored in the rope. So this is meaning of this one, means why EP has been increased, because more work is done by the same force, because same force has been applied for longer displacement. So simply we need to write down, in this case delta X increases, so EP increases, and this question has 2 marks. Now let me show you the answer, how you can write down your answer. This is how you can write down your answer. You can mention these 2 points in your answer. If you have mentioned these 2 points, you will get 2 marks. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. And if you need more help, and also if you're looking for extra resources like worksheets, topic wise notes and questions, please check Patreon. And the link for Patreon you can see in the description of this video. If you have any questions, please leave your questions in comments. I will try to answer as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 Paper 2 Variant 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 3 says, a trolley A moves along a horizontal surface at a constant velocity towards another trolley B, which is moving at a lower constant speed in the same direction. Figure 3.1 shows the trolleys at time t is equal to 0. Table 3.1 shows data for the trolleys, means the mass of the trolleys is given to us and the initial speed of the trolleys is also given to us. The two trolleys collide elastically and then separate. The resistive forces are negligible. It means momentum is conserved. So law of conservation of momentum we can apply because there are no net external forces acting on this system. And this clearly is elastic. So these are some important points you need to understand before you start working on answer. Part A says, state what is represented by the area under a velocity time graph. What is this area representing? Mean area under VT graph, this area. What this area is representing? This area is simply representing displacement. So very basic point, you need to be very clear. What is the area under velocity time graph? That area is displacement. And this question has only 1 mark. If you have written displacement, you will get 1 mark. Part B says, use table 3.1 and figure 3.2 to determine the acceleration of trolley B during the collision. So we need to determine the acceleration of trolley B, means the time when there is net force acting on trolley B, and that net force is when these two trolleys they collide with each other, they will exert force on each other, and that force has same magnitude but opposite direction. And that single force, because that is the only force acting on the trolley, that single force mean along horizontal. Of course weight is down, we are talking about along horizontal. That is the single force, and that single force will change the velocity and that will cause acceleration. Few points you need to understand. First thing you need to understand, when two bodies collide, let's say we have body A and let's say here we have body B. When two bodies collide, what is same for A and what is same for B? You can write on your own answer and then I will explain. The first thing you will simply say, the force on two bodies will be the same in magnitude but in opposite direction. So this is one thing we can say, same for A, same for B. So first of all, force is the same. The second thing you need to understand, time of impact, or we can say time in contact, that time is the same. Now what else is the same? If force is the same, net force on two bodies is the same, time is the same. So we can also write down this is delta t. So it means force time delta t also is the same for trolley A, same for trolley B. So it simply means that the change in momentum of these two trolleys will be the same, mean the momentum will change by the same amount but in opposite directions. So we can also say this one is impulse. So the impulse on trolley A and impulse on trolley B will be the same. These are some very important points about momentum you need to understand. So they can ask you these points next time. So these are very important points when two trolleys collide. What is same for A? What is same for B? I hope this makes sense to you. Now you see, as direction of forces is opposite, so it means change in momentum for trolley A and change in momentum for trolley B also will be in opposite directions. So these are the points you need to understand. Now for this question, if you look at this part before this, you can see the speed is constant. It means that there is no net force acting on the system, means acting on this trolley. This is for trolley B. This is for trolley B. And if you look at this point and this point, velocity is increasing. It means there is force on trolley B. So simply we need to find the gradient of this, because we have velocity against time graph, so we need to find out the gradient. So we can mark these points, we can mark this point, we can mark this point, and then simply we can find acceleration. So first of all, we can mark these points. So these are the coordinates. So we need to find out acceleration. This will be simply equal to delta V by delta T, means the gradient of this part of the graph. So we have value of y here, that is 0.30 minus we have 0.12 divided by 0.35 minus 0.15. So if we solve this one, we will get 0.90 meters per second. So this is our answer. So this is acceleration of trolley B. But acceleration of trolley A, is it also the same or not? Acceleration of trolley A is not same as acceleration of trolley B, because acceleration A, this is equal to net force divided by mass. Even this is the same. If the mass of trolleys is different, so the acceleration will be different. I hope this question makes sense to you. This question has 2 marks. If you have written these steps, you will get 2 marks. So try to understand physics, not just try to memorize, because patching in physics is not good. Try to understand the whole in a proper way, the whole story. Try to listen always the whole story. So try to understand the whole physics, not just patching one concept. So that will never help you to improve your understanding of physics. Second part says the magnitude and direction of the final velocity of trolley A, means calculate the magnitude and direction of the final velocity of trolley A. For this trolley, we need to find out what is the final velocity of trolley A. But for this question, we have the mass of trolley A, we have the mass of trolley B, we have the initial speed of trolley A, we also have initial speed of trolley B. And also we can find the final velocity of trolley B from this graph. And VB, we can say that is equal to 0.30 meters per second, and this is positive, and this value is positive. It means this trolley is moving to the right. So this is VB, and VB is to the right. In any question, if it is not given to you, to the right is positive, or to the left is positive, or up is positive, or down is positive, by convention to the right we take positive, and upwards we also take positive. So these are the conventions you will see in the exams, and also you will see in different textbooks. So we follow these conventions. So this is first thing you need to understand. Now simply in this case, in the question it was given to us, there is no net external force acting on the system. So it means in this case the change in momentum is equal to 0. So it simply means that the initial momentum, this is equal to the final momentum. Momentum is a vector quantity, so direction of the momentum before and after also is the same, and magnitude of that momentum before and after also is the same. Now simply we have trolley A, this is moving to the right. We have mass of this one, we can say this is M1 U1 plus M2 U2. This one has to be equal to M1 V1, so mean this is for trolley A, V1 plus M2 V2. Now simply we need to plug in values. Mass of trolley A we have, that is 0.25, and trolley, this is initial speed is positive, velocity is positive, trolley is moving to the right, plus for the second trolley, mass we have, that is 0.75, then this trolley is moving to the right because this is positive, so we have this is 0.12, and we have the mass of trolley A here, so that is equal to 0.25, and we need to find out VA. So here we have mass of trolley B, that is 0.75, and the velocity is positive because this is given to us is positive, so trolley B is moving to the right, so we can write down here 0.30. Now if we solve this one for VA, we will get minus 0.060 meters per second. This negative sign is very important. Let me rewrite this one. Maybe this is not very clear. So it is negative 0.060 meters per second. And here we have negative sign. So here we have this negative sign. So what is significance of this negative sign? This negative sign simply is telling us direction of trolley A after clearance is opposite to this one, is opposite to our sign convention. So it means trolley A after clearance, this is moving to the left. So you can also find direction from here. So direction is to the left. So this is how you need to answer. Physics is your way of thinking. Physics is fun and physics is beautiful, and beauty and fun is in your mind. If you love physics, you do problems, you will love problems. You will never get tired of that. So try to understand physics, try to develop love for physics by understanding physics in a right way. Part C says, on figure 3.2, sketch the variation of the velocity of trolley A with time t from t is equal to 0 to t is equal to 0.50 seconds. So for this purpose, we need to understand what is the initial speed of trolley A and what is the final speed of trolley A. Final speed of trolley A we have found that is equal to negative 0.060 meters per second. And the clearance is taking place here, so we can draw the line. So the clearance is taking place here. It started here and clearance stopped here. So at this point it stopped. So here clearance is taking place. So it means before clearance and after clearance, velocity of trolley A is constant. You also need to understand why velocity will be constant, because there is no net external force acting on the system when these two bodies are away from each other along horizontal. So that's the reason velocity need to remain constant. And in this interval, when they collide with each other, the velocity is changing because there is net external force on trolleys. So how we can sketch? So the beautiful way to sketch this one is simply you need to look at initial velocity 0.48, and this is positive. So simply 0.48 is here because this is 0.4, this is 0.5, so this is 0.48. So simply you can draw line here. So this is initial, and the final we can draw negative 0.060. so here we have 0.1, so this is 0.0, so this is 0.02, 0.04, 0.06. so we can draw the line here. Now simply we need to connect these two by a straight line, because acceleration is constant, because the net force is constant. So the gradient of this line has to be constant. As the speed of trolley A is decreasing, so it means acceleration is in opposite direction of motion of the trolley. So the gradient has to be negative. So this is how simply you need to sketch. Now let me clear the extra lines. So these lines we can simply clear. You don't need these vertical lines. So the final answer you can simply draw like this. So let me show you how you can sketch the final. So simply you can draw line like this. I hope this one is clear to you, and you also understand why it has to be aligned with constant negative gradient, because acceleration is constant, because resultant force on the trolley is constant. Question 4 part A says, state the principle of superposition. This question is a typical question you will see in almost 70% past papers. Mean this question is in about 70% of past papers. So you need to understand how to state principle of superposition in a proper way so you can get 2 marks. In order to define principle of superposition, you can say when two waves meet at a point, the resultant displacement of resultant wave is the vector sum of individual displacements of individual waves at that point. Now let me write down this one for you. So simply you can say the resultant displacement at any point is the vector sum the vector sum of individual displacement. So we can say vector sum of individual displacements. So this is how you can simply define principle of superposition. Now let's try to understand this one with the help of animation. If you look at this animation and if you look at this point, at this point you can see the resultant displacement of resultant wave is always 0. It means that at this point one wave has positive displacement always, and one wave means the other wave always has negative displacement, and the magnitude is the same, so the resultant is equal to 0. So particle of medium at this point will always be at rest, mean this is the node actually, so there is no displacement. So this is what principle of superposition is telling us. Now let me show you the answer, how you can write down your answer. In your answer you have to mention these points. You can say when two or more waves overlap at a point, displacement of resultant wave is the sum of individual displacement. So it's better to say vector sum. So vector sum is very important. Part B says calculate the wavelength of the light, and this question is a typical question about double slit experiment. For this question, the distance between slits and screen is given to us. We can say this distance is capital D, and slit separation is given to us. We can say this is small t. This is the distance between center of one slit to the center of another slit. And also we have fringe spacing, mean the distance between centers of two bright fringes is given to us. We can say this is x. So for double slit experiment, you need to understand the product of lambda times t. This is equal to d times x. We need to find out value of lambda, so simply we can make lambda the subject and we can find its value. We have d, that is in millimeters, so we need to convert this one into meters. Value of x is also in millimeters, so we can convert this one into meters as well. So we can write down here 1.7 times 10 to minus 3, so this is in meters. Now we can divide by the distance between screen and slits, that is already in meters. Now if we solve, we will get 5.8 times 10 to minus 7 meters. So this is value of lambda. If you have written these steps, you will get 3 marks. Part C says light waves from slits X and Y in B arrive at a point between adjacent bright fringes on the screen. Figure 4.2 shows the variation of displacement with time for the waves arriving at the point where they meet. The student makes two statements about the waves at this point. Statement 1, the phase difference between the waves is 90 degrees. Statement 2, the amplitude of the resultant wave is 0. Explain how statement 1 is correct. If you look at this point, this wave has 0 displacement and this wave has maximum displacement. It means the phase difference between them is 90 degrees. But the better way to understand this one is we can extend this line, and we can draw these waves. So this wave, if we go back in time, we can imagine it's coming from this point, it's starting from this point, and this wave at this point, this has already reached the peak, so it is starting from here. So what is the phase difference between these two? So the phase difference between these two is 90 degrees. So when it has 0 displacement, this has already reached the maximum displacement. So the phase difference between these two is 90 degrees. So this is one point you need to write down. So let me show you the answer. In your answer, you can write down this point. Simply you can say one wave has maximum displacement, other wave has 0 displacement, means at this point. Second part says state and explain whether statement 2 is correct. Statement 2 is telling us that amplitude of the resultant wave is 0. But if you look at the resultant displacement, means if you look at this point, the resultant displacement is equal to this value. So this is not 0. And if you look at this point, resultant displacement will be equal to this value. So it means this is in incorrect. Why this is incorrect? Because the phase difference is 90 degrees. If resultant wave displacement is equal to 0, so the phase difference has to be equal to 180 degrees. So there will be destructive interference. But in this case, phase difference is 90 degrees, so it means that statement 2 is incorrect. Destructive interference, 100% destructive interference, this one will take place if phase difference is equal to 180 degrees. That phase difference is not equal to 180 degrees, so it means this statement is incorrect. So first thing we need to write down statement is incorrect, then we need to explain why this is incorrect, because phase difference is not equal to 180 degrees. In these points we can write down answer. So if you write down, you will get 1 mark. First thing you need to say it is not correct, so this is you need to state, then you need to explain, because phase difference is not equal to 180 degrees. Part D says the width of each slit in B is decreased by the same amount. There is no change to the separation of the slits. It means value of D remains same. So very important point. Describe and explain the effect, if any, of this change on the appearance of the interference pattern. Means what is the effect of this change on this pattern. So first of all, we need to understand we are talking about double slit. So from here we can say x will be equal to lambda times capital D divided by small d. As all these quantities are the same, d is the same, small d is the same, capital D is the same, and we are using the same light, it means x is also the same. So it means that the fringe width is the same, means the fringe spacing are simply, you can say fringe width, or you can say fringe spacing, this one will remain same. So this is one thing. Now as this gap size decreases, this gap size decreases, so how about the light coming out of this one? So it means less light is coming, so we can say, so less light is coming, so it means that the bright fringes, they will be dimmer, so we can simply say bright fringes, they will be dimmer, because when two bright fringes are formed, they are formed due to constructive interference between two waves coming from these two slits. If the coming waves, they have smaller amplitude, so the resultant amplitude also will be smaller. So let me explain you this one in a little bit different way. First of all, you can imagine we have waves, they are coming with this amplitude, so the amplitude is this big. So if these two waves they meet, we will see this super wave. But now size will decrease, it means the amplitude of the waves coming out of this one will decrease, means the less light is coming, simply we can say less light is coming, less light, so it means the amplitude will decrease. If more light is coming, more waves are coming, it means the amplitude will be greater. If the less light is coming, amplitude will be small. So now the amplitude is small, means less amount of light is reaching this screen, so in this case we will see this. So it means that bright fringes, they will be dimmer, but dark fringes, they are still the same, dark fringes. So here we have this one, so you can also draw here, so we have this, and before we have this, so what is the resultant of these two? No light. Now we have this case, we have here and we have here. What is the resultant? No light. So no change to dark fringes, but the brightness of bright fringes will decrease because less light is coming out of these slits now. I hope this makes sense to you. One thing more we need to understand. We need to understand diffraction actually. One very important point about diffraction we need to understand. When lambda of the wave is almost equal to the gap size, significant diffraction takes place if these two quantities are almost same. But if we decrease this one, gap size we decrease, but we keep this one same. In this case, diffraction increases. So you need to understand diffraction decreases and vice versa is also true. It means these waves coming out of the slits, they will spread out more. So it means we will see more bright fringes, more number of bright fringes on the screen. More bright fringes on the screen because diffraction increase, it means more fringes we will see. More fringes as diffraction increase. You can also write down spreading out more. Wave spread more. So simply we can say wave spread out more. We can say spread out more. As they spread out more, it means we will see more fringes on the screen. Beautiful question. These are the points you need to understand. And so one point is this. You have to write on this one in your answer. You will get 1 mark. And the second one, the bright fringes, they get dimmer. So bright fringes, we can say they get dimmer. You will get mark for that one. And also if you write down they spread out more, number of bright fringes increases. So this can be the second point. This can be the third point. So you need to write down these 3 points. And this question is a beautiful question. If you understand this question well, it means a lot of questions about waves, especially about Young's double slit experiment, you can answer. I hope this question makes sense to you and also you have better understanding of these exam questions. If this video was helpful, please like and subscribe, and also you can join Patreon for more resources. You can also share this channel with your friends so they can also get benefit from these videos. And the solution of remaining questions I'll upload as soon as possible. And also on the channel you can see a lot of videos. You can watch them, especially the topic wise. You can also find more than 60 past papers solution on this channel. So if you really want to improve your understanding of physics and you watch those topic wise questions and also you watch full solutions, it's quite possible you will have very good understanding of physics and you will get maximum marks in your exam. Means you will be able to get the highest possible grades in your final exam. Now let me show you the answer. For the answer of this question, simply you can write down these points. You can simply say the first point. You can say more diffraction of light by slits because gap size decreases, it lambda is the same, so it means more diffraction. So 1 point you can mention. Light from slits have less intensity, means less light is coming out, and more bright and dark fringes because this will spread out more. Bright fringes are dimmer because resultant, here you can see we have mentioned this point here, because less light is coming, so the resultant wave will have smaller amplitude. And dark fringes, there will be no change due to destructive interference because the size of the slits decrease by the same amount. If the size of the slits will decrease by different amounts, then dark fringes, they will be brighter. Maybe they can ask you this one in next exam or any other time. So this is how you need to answer. I hope these things make sense to you. And also if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, Paper 2, Variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 5 says, a train travels at a constant high speed along a straight horizontal track towards an observer standing adjacent to the track as shown in figure 5.1. The train sounds its horn continuously as it approaches the observer from time t is equal to 0 until it is well past the observer at time t is equal to t2. The train passes the observer at time t is equal to t1. The horn emits a sound wave of constant frequency fs. On figure 5.2, to sketch the variation of the frequency of sound heard by the observer with time from time t is equal to 0 to t is equal to t2. This is a typical question about Doppler effect. Few points we need to understand. For this question, when the source is approaching, observer in this case is at rest. So when source is approaching, how frequency will change? Source is approaching, so the observed frequency will be equal to speed of the wave divided by speed of the wave minus speed of the source. Speed of the source. And we need to multiply this one with frequency of the source. So in this case, observed frequency, this will be greater than frequency of the source. So this is one thing we need to understand. And the second, when the source is moving away. So we can write down the second case when the source is moving away. So we can simply write down moving away. In this case, observer is always at rest. So we can simply say when the source is moving away. When the source is moving away, observed frequency will be equal to speed of the wave divided by speed of the wave. Speed of the wave means speed of the sound in this case, plus speed of the source multiplied by frequency of sound produced by source. So in this case, observed frequency will be lower than frequency of the source, because in this case denominator is greater than numerator. So this is our numerator. So observed frequency will be lower, and observed frequency, if the speed is constant, observed frequency will be constant. So these are the points you need to understand. In this case, as this denominator is smaller than numerator, observed frequency will be greater, but this one will be constant. So we can also write down for simplicity, observed frequency will be equal to some constant, means constant factor from here, time fs. And here we can also say observed frequency in this case will be equal to some constant factor. This is a constant factor because the speeds are constant, so that's the reason heard frequency will be constant, means the observed frequency times fs. We can say this is k1 and this is k2 because these are two different constants. Now we need to sketch this one. So the shape of the graph, simply I hope you will say it has to be constant here. So let me use different color. So it has to be constant, so frequency has to be constant. So heard frequency has to be constant, and this one has to be greater than frequency of the source. So that's the reason we have drawn this is higher, and in this region it has to be lower, and it will decrease by about the same amount. So you can draw another horizontal line here. So these two horizontal lines you need to draw. You can also connect them by a line like this. This question has only 1 mark. Wow, only 1 mark. So if you sketch one horizontal line here, one horizontal line here, you will get 1 mark because this question has only 1 mark. Part B says at a particular time the sound waves at the observer have an intensity of 4.7 times 10 to minus 3 watts per square meter. The waves at the observer are incident at right angles on a circular detector of radius 2.8 centimeters. Calculate the power P of the waves incident on the detector. So in this case, intensity of the waves is given to us. So simply we can imagine waves, they have certain intensity. So we can imagine these are the waves, they are coming with certain intensity. And one detector is placed in front of them, and we can calculate area of this detector. So this one is our detector. So question is simply asking us what is the power reaching this surface. So power simply is equal to intensity times area. So power will be equal to intensity. Value of intensity we have, that is 4.7 times 10 to minus 3 watts per square meter. And area of circle we can find, that will be equal to pi times r square. And so simply we can write on here power will be equal to 4.7 times 10 to minus 3. So this is the intensity, and we have pi multiplied by r. R is given to us, that is 2.8. We need to convert this one into meters. So this is our radius square. And if we solve this one, we will get 1.2 times 10 to minus 5 watts. So this is the power incident on this circular detector. So this is how you can calculate. So this is our final answer, and this part has 3 marks. So this part has 3 marks. So quite straightforward question if you understand the question. Question 6 says a battery is connected in a circuit with a light dependent resistor, 2 fixed resistors and a voltmeter as shown in figure 6.1. The battery has an electromotive force of 25 volts and negligible internal resistance. The resistors have resistances of 320 ohms and 240 ohms. The voltmeter displays a reading of 16 volts. Mean reading on this voltmeter is 16 volts. Show that the current in the battery is 0.050 amps. Now we need to understand the current coming from the battery. So this is the current, and this total current is passing through this resistor. We have potential difference across this resistor and we have resistance of this resistor. So simply we can say current will be equal to PD across this resistor, potential difference across this resistor, divided by the resistance of this resistor. So we can say capital R. We have PD across this one, that is equal to 16 volts, and resistance of this one is 320 ohms. Now if we solve this one, we will get 0.050 amps. So this is our answer, and this question has 1 mark. If you got the right answer, you will get 1 mark. Second part says calculate the resistance of LDR. In order to calculate resistance of LDR, first of all we need the PD across this combination. So we can connect voltmeter here. So simply we can say voltmeter is connected here. Now what is the reading on this voltmeter? Reading on this voltmeter we have that is equal to 16 volts. So reading on this voltmeter has to be 9 volts because sum of these two has to be equal to 25 volts. Now we can also imagine an effective resistance here that can replace these two resistors, and we can say the resistance of this effective resistance we can draw here, we can say is capital R, and we have PD across this one that is equal to 9 volts. So how much current is passing through this effective resistance, or we can say total current passing through LDR and 240 ohms resistor. That current is the same as current coming from the battery because they are connected in series. So you can imagine this is in series with this one, so current is the same. So current is 0.050 amps. You can also understand the total current passing through LDR and 240 ohms resistor is the same as current coming from the battery because this combination is connected in series with this resistor and they are connected in series with the battery. So current is the same. So simply we can say current here, this is equal to 0.050 amps. So we can find out value of R from here. R will be equal to V divided by I. Value of V we have that is 9 volts and current is 0.050 amps. If we solve this one, we will get 180 ohms. So we have the total resistance of this parallel combination. So for parallel combination, we can simply say 1 over R. This will be equal to 1 over 240 plus 1 over resistance of LDR. We need to find out resistance of LDR. We can say R LDR. This will be equal to 1 over capital R minus 1 over 240. R is equal to 180 minus we have 1 over 240. From here we can take LCM. We can say this is 240 multiplied by 180. So we will get 240 minus 180, and this will be equal to 60 divided by 240 times 180. So this is 60. So here we will get 3. So this is 3. Now simply I'll be writing here. So now simply we have 1 over resistance of LDR that is equal to 1 over 240 times 3. So it simply means that resistance of LDR, this is equal to 720 ohms. So this is how you can answer this question. Simple question, but conceptual question. If your basic concepts are not clear, maybe you will struggle with this question. Third part says determine the ratio between the power dissipated in LDR and power dissipated in 240 ohms resistor. So first of all, how we can calculate power dissipation, means the power dissipated in any resistor. We have different ways to calculate. We can calculate by V square by R. We can also calculate by V times I. We can also calculate by I squared times R. If we have current passing through resistor and we have PD, we can use this one. If we have PD across resistor and we have resistance of resistor, we can use this one, and we can use this one if we have current passing through that resistor and resistance of that resistor. But if you look at this question, for this question we have PD across these two resistors, that is equal to 9 volts, and also we have their resistance. Resistance of LDR we have calculated, that was equal to 720 ohms. So we will be using this equation. And so simply we can write on the ratio between these two. Power dissipated in LDR, that will be the PD across LDR, divided by resistance of LDR, multiply by, because this is in denominator, so this will be 240. So here we have 240 divided by V square. V is the same, so this V with this V will be cancelled. So we got 240 divided by 720. If we solve this one, we will get, this is the ratio. So this is our final answer. Part B says the intensity of the light incident on the LDR increases. State and explain what happens to the voltmeter reading. So for this question, first of all, we need to understand how intensity of light, increase in intensity of light, it will affect the resistance of LDR. So for that purpose, you need to understand how resistance of LDR changes with light intensity. So here we can sketch, this is light level. As intensity of the light increases, resistance of LDR decreases. So this is, you need to understand how resistance of LDR decrease with light level. So in this case, intensity of light is increasing. So we have intensity of light that is increasing. So it means resistance of LDR has to decrease. So this is first thing we need to understand. Now we need to understand, if resistance of LDR decreases, what is effect on resistance of this parallel combination? So we can write down R parallel, how it will change. If resistance of LDR decrease, so resistance of parallel combination will also decrease. If resistance of this parallel combination decrease, means here we have lower resistance, so it means total resistance of the circuit, we can say, or total in the circuit, that will decrease. If total resistance of the circuit decrease but PD is the same battery we are using with the same potential difference across terminals, it means that current in the circuit, I total, current in the circuit will increase. If I total increase, so it means current passing through this resistor will increase, but resistance of this resistor is fixed. So it means that V is equal to I times 320 ohms. So if I increase, so it means value of V means the PD across this resistor, or we can say reading on this voltmeter, that will increase. So these are the points you need to understand. You need to understand in a logical order, so you can improve your understanding of electricity. I hope this question makes sense to you. If you have any question, you can ask me, and if this video is helpful, please like and subscribe, because your encouragement is very important. For this part, you need to understand resistance of parallel combination. If the resistance of one resistor decrease when resistors are connected in parallel, total resistance decreases. So this is the main point you need to understand, because resistance of parallel combination is always smaller than the smallest resistance in that parallel combination. So if these points are clear to you, now we can write down our final answer. In the final answer, we can mention these points we have already discussed. First, we can say as resistance of LDR decreases, resistance of parallel combination also decreases. So very important point. Total resistance of circuit decreases, as we have discussed here. Total resistance of circuit decreases, so current in 220 ohm resistor increases. So we have discussed total current increase, it means current in 320 ohms resistor also increases. So hence voltmeter reading increases. So this voltmeter reading will increase and PD across this combination will go down. So they can ask you next time, so PD across this parallel combination, it will go down. Question 7 part A says the results of the alpha particle scattering experiment led to the development of the nuclear model for the atom. State the results that suggested that most of the mass of the atom is concentrated in a very small region and most of the atom is empty space. So these are the conclusions. So we need to write down the observations. Empty space, this is conclusion of most of alpha particle, most of the alpha particles, they went straight through, means nothing is there, went straight through the gold foil, so we can say straight through. So this is observation of this conclusion. Mass is concentrated, so the second conclusion is mass concentrated, mass concentrated, because very few alpha particle, they just deflected back, very few deflected back. So we can say very few deflected back. So this was the observation. So here we have observation and this was our conclusion and this was the observation, then this is the conclusion. So we have two conclusions, we need to write down two observations. So here we have these two observations. A very small portion of alpha particles deflected back through large angles, or simply you can say just deflected back. So it means mass is concentrated, mass and charge are concentrated in a very small tiny region, and that tiny region was nucleus. A large portion of alpha particles pass straight through, it means most of the atom is empty space. So this is how you need to write out your answer. For part B, we need to state the composition of gamma radiation. Gamma radiation is electromagnetic wave. So simply you need to say this is electromagnetic wave. So if you write down this one, you will get 1 mark. Part C says table 7.1 lists the names of theory particles and possible classifications for them. Complete table 7.1 by placing ticks in the boxes to indicate the classifications that apply to each particle. Neutrino. Neutrino is not baryon because baryons, they have 3 quarks. So neutrino is not baryon and it is also not hadron. Neutrino is lepton. Neutron, it has 3 quarks, 2 down quark, 1 up quark. So this one is baryon and this is also hadron. It is not lepton. Positron, this is antiparticle of electron and electron is lepton. So positron is also lepton. Part D says the discovery of a particle with an unusual charge was an important step in the development of the theory of quarks. The particle is a hadron with a mass of 2.19 times 10 to minus 27 kgs and a charge of plus 2e, where E is the elementary charge. Calculate the mass in U of the particle, give your answer to 3 significant figures. So for this question, mass is given to us in kgs, so we can say this is 2.19 times 10 to minus 27 kgs. We need to convert this one into U, means into atomic mass unit. So for this question, simply we need to understand 1 U means 1 atomic mass unit. This is equal to 1.66 times 10 to minus 27 kgs, and this value means the value of this constant is given in the data. On the second page of your exam paper, you can find the values of constants. Now we need to convert this one into U. So we can write on 2.19 times 10 to minus 27 kgs. We wanna convert this one into U, so we can write down U here. So 1 U here, and 1 U is equal to 1.66 times 10 to minus 27 kg. This is a beautiful way to convert unit from one unit to another unit. So we can simply write on here. So you see kg, this unit you can cancel with this one. Now if we simply 10 to minus 27, we can cancel with 10 to minus 27. So simply you need to divide now 2.19 by 1.66. So if we solve, you will get 1.319. Our answer has to be up to 3 SF, so we can write down 1.32. So this is our final answer. So this is how you need to convert units. A beautiful way, very nice way. Always follow this one. So in this case we need U, so we can write down U in numerator. We want to get rid of kgs. We can write down 1U is equal to how many kgs here. So then you can cancel and you can find the final answer. Second part says determine a possible quark composition of a hadron with a charge of plus 2e. Explain your reasoning. They have made this question a little bit tricky because they are telling you this is a hadron, and hadron can be baryon, it can be classified into baryons, and it can also be classified into mesons. Mesons, they consist of one quark and antiquark, so the charge plus 2e is not possible. Mesons, they cannot have charge plus 2e, so it means this is not possible. So it has to be a baryon, so it consists of 3 quarks. So baryon consists of 3 quarks. Now we need to understand the charge on the quarks. Up quark, this has charge plus 2 by 3e. Top quark, this has charge plus 2 by 3e, and the charm quark also has charge plus 2 by 3e. So simply plus 2e charge is possible if we have one up quark, we have one top quark, so we can say top quark, and one charm quark. So this combination is possible. This is also possible if we have two, let's say, up quarks and we have one charm quark. This is also possible if we have two top quarks and we have one charm quark, and we have two charm quarks and we have one up quark. So these are some possible combinations. If you write on any of them, you will get 2 marks. So you can write on simply it's a combination of these 3 quarks. You can also write on this one. Any one is acceptable. Total charge has to be equal to this. So any combination is acceptable. And that's all for this paper. We have answered all the questions from this paper. I hope this video was helpful, and if this video was helpful, please like and subscribe. And if you're looking for extra resources, especially worksheets with detailed answers, not just answers from the mark scheme, detailed answers to improve your conceptual understanding and also to clear your doubts, then you can check Patreon. On Patreon you can see a lot of resources. And if you have any questions, please leave your questions in comments and I will try to answer as soon as possible.